Pag-aaralan natin ang mga applications of quadratic functions. Now, there are a lot of problems or scenarios in real life where it can be modeled or solved using quadratic functions. So, first example, if the perimeter of a rectangle is 64 meters, find the dimensions of its area if it is a maximum. So, bago natin isolve ang problem na ito, kailangan nating ma-understand or kailangan nating maintindihan yung problem. So, we have here, it was stated here, perimeter. Perimeter ng ano? Perimeter ng rectangle. The shape is rectangle. So, ano ba yung perimeter? So, yung perimeter is the sum of all the sides ng rectangle. So, we have 4 sides. So, 1, 2, 3, 4. Yung shape natin is rectangle. It has the dimensions which are the length at saka width. Okay? So, since opposite sides ng ating rectangle are equal, so meron tayong dalawang length sides, kaya siya 2L, kasi meron tayong dalawang length na sides, at saka dalawang width na sides, ito siya, at saka ito. So, since yung sum ng ating sides is the perimeter, so kaya yung formula ng perimeter is 2L plus 2W. So, that is our perimeter formula. And in our case, yung perimeter natin is 64 meters. That's our perimeter. So, it is already given. What we are asked to find is, kailangan nating hanapin yung dimension. It means, what would be the length and the width para yung area natin, okay? Yung area is the space inside the rectangle. So, we have to find what should be our length and our width so that the area is maximum. Ibig sabihin, we want the area to be the highest possible value. Okay? So, ano kaya yung pwedeng length at saka width ng ating rectangle? We have your table of values kung saan yung width ay given. So, the length is unknown and we have to find the area by just simply multiplying length times width. Kasi area ng rectangle is multiply lang natin yung length at saka width. So, how do we find the length? Now, since the perimeter of the rectangle is already given and the width is also given, we have to find the value of the length using the formula for the perimeter. So, to solve for that, okay, we know that our P is 64. So, replace natin yung P natin dito with 64. Okay. And then, since the width is already given, we will transfer 2W to the other side. So, we have 2L equals 64 minus 2W. And then, for L to be left on the other side, we have to divide both sides by 2. So, L can be found using 32 minus W. So, we will use this formula to find our length. The first column is already solved for you. If the width is 2, then the length is 30. So, multiplying the length and the width, so 2 times 30, that is 60. How about if the width is equal to 4? So, length is equal to 32 minus 4, and that is equivalent to 28. So let's write here 28. Now to solve for the area, multiply 4 and 28. So the answer is 112. Okay, next, how about if the width is 6? So length is equal to 32 minus 6. So that is equal to 26. So this is equivalent to 26. Then we have to multiply 6 and 26. So the answer is 156. Next, if the width is 8, then the length is 32 minus 8, and that is equivalent to 24. So let's write here 24. And 24 times 8, and that is equivalent to 192. So if you notice the pattern for the length and the pattern for the width, so the width is increasing by 2 while the length is decreasing by 2. So basically this will be 22, this will be 20, this will be 18, and this will be 16. Okay, now let's find the area if our width is 10 and if our length is 22. So that is equal to 220. So if you notice, our area is gradually increasing. We have to find the maximum area or the highest area for this scenario or for this problem. So next, 12 times 20, that is 240. Okay, and 14 times 18, that is 252. And 16 times 16, that is 256. So if we add another column here, this will be 18. And if the width is 18, then the length must be 14. Okay, and 18 times 14, that is 252. Okay, another one. If we add another column here, that's 20. And if the width is 20, then the length is 12. And 20 times 12, that is 242. So if you notice, 252 is the same here. And 240 is also the same here. So it goes up to the highest point, which is 256, and then it goes down the same value with what we had on the left side. It's the same thing as graphing that in the parabola. So this will be the behavior of our area. So it gradually goes up and up, and then it reaches its maximum area, and afterwards it goes down. So that's a parabola facing downwards. So our maximum area here is 256 meter squared. With the dimensions, our length is 16 meters, while our width is 16 meters also, and it produces the maximum area of 256 meter squared. Here are some questions. Express the area A of the rectangle as a function to its width W. So we have to find the area A of W. So we know that the area is length times width. So since it's a area of W, we have to express L in an expression where it has to be W as the letter on it. So we know that we had solved earlier L is equal to 32 minus W. So instead of writing L, we will use this one so that we have W as the variable. So A of W is equal to L. L is 32 minus W, and then multiply it by W. So simplifying that, that is A of W is equal to 32 W minus W squared. So this is an area with as a function of W. Okay. What kind of equation is the result? So basically that is a quadratic function. And then express the function in a standard form. So we have to write this one in the standard form. So A of W is equal to negative W squared plus 32W. So that's the standard form. How about the vertex? So vertex H and K. So H is solved by negative B over 2A. So our A here is negative 1 and our B is 32. So solving H, we have negative 32 over 2 times negative 1. So that is negative 32 over negative 2, and that is equivalent to 16, positive 16. So our vertex is 16. Then solving for our K. Okay, so to solve for K, we will just substitute 16 to W here. So negative 16 squared plus 32 times 16. So this one is different from negative 16 squared. So it's not the same with this because negative 16 squared means that there's negative 1 here and then you have 16 to the power of 2. So negative here is not included inside the parentheses. So you have to be careful with that. So this is negative 256 plus 32 times 16, that is 512. So since we are adding different signs, we have to subtract. So negative 256 plus 512, so subtracting them, that is positive 256, which is our area, right? So this is 256. So basically our H here was our width, and our K in application to the problem is actually our area given the width. So we have here another example. We have the graph. On the x-axis, we have the time in seconds, and on the y-axis, we have the height in meters. So we have the graph here, a parabola facing downward. Now the first question, what is the maximum height reached by the projectile? So obviously the maximum height is 30 meters. Okay, so that is 30 meters. Because if you notice, it's aligned to our the point having the y coordinate of y, which is 30, or the height of 30 meters. Then how long does it take for a projectile to reach the maximum height? So obviously our time here is between 4 and 6, and obviously that is 5. So that's 5 seconds. Okay, that's 5 seconds. Next, how long does it take for a projectile to return to the ground? So if this is our object in a projectile motion and it reaches the ground at 10 seconds. What is the axis of symmetry of the graph? So remember that the axis of symmetry is, it's a line passing through our vertex. So this line is x equals h, and that is, what is our h? So if this is our vertex here, the h, which is 5 for the x, and then the k, which is, or the y, which is 30. Okay, so our axis of symmetry is x is equal to 5. So the vertex of the graph is obviously 5 and 30. That's the vertex. Example 1, number problem. Find two real numbers whose sum is 14 and whose product is maximum. So there are two numbers, and if we add the numbers, their sum is 14, and if we multiply them, their product is maximum. So we have there some representation. So let x be the number, or the first number. Since their sum is 14, so the second number would be 14 minus x. And p of x is the maximum product. Now, since this is a quadratic function, then we can multiply the two numbers. This is our first number and this is our second number. So p of x is the product of the two numbers. So the first number is x and the second number is 14 minus x. So this is a quadratic function. P of x equals, that is 14x minus x squared, or in the standard form, that is p of x equals negative x squared plus 14x. So if we can solve for the h, then we can substitute the value of h to our x. Okay, so let's solve for the h. So the h is actually our x, right? So let us solve for h here, which is equivalent to negative b over 2a. And our a is negative 1 and our b is 14. So negative b, which is negative 14 over 2 times negative 1. Negative 14 divided by negative 2, that is positive 7. So 7 is our first number. Okay, so how about the second number? Since x, or the h, which is 7, then the second number, so first number is 7, x equals 7, and the second number is, so since we know that the other number is represented by 14 minus x, we can solve that one as 14 minus 7, which is 7. So the first number is 7 and second number is 7. So it reaches the maximum product of 49. Okay, so the maximum product, okay, which is 7 times 7, that is 49. So, since we are asked to find the two real numbers only, then the two numbers are 7 and 7. Example 2, geometry. What are the dimensions of the largest rectangular field that can be enclosed by a 60 meter of fencing wire? So imagine that you have a rectangular field and you want to enclose it by the fencing wire, and that fencing wire has a perimeter of 60 meters. So imagine ito yung blue natin. So yan yung blue. The length of that blue fencing wire is 60 meters. So yung perimeter natin is actually 60 meters. Now, we are asked to find the dimensions. So gagamitin natin yung knowledge natin that the perimeter ng ating rectangular field is 60 meters. So 60 is equal to 2L plus 2W. So, ano kaya yung pinakamalaking rectangular field na pwede nating mabakuran ng 60 meters na fencing wire? So, since all of the terms can be divided by 2, so pwede natin i-divide lahat yan by 2 para mas maging reduce yung expression natin or equation natin. So, that is L plus W equals 30. Okay, so let's say this is width and this is our length. Okay, hindi pwede na dalawa yung unknown variable natin. Kailangan ma-express natin siya in such a way na isa lang yung unknown variable natin. So, anong gagawin natin? For the L, okay, we will solve this equation na W yung nasa right side ng ating equation. So, L is equal to 30 minus W. So, in-express natin siya in such a way na we are solving for W. Yung variable natin dito is yung W. So, instead na L yung gagamitin ko, I will replace the L with the equivalent expression niya, which is 30 minus W. Okay, since equal lang naman yan sa L. So, nakikita nyo, napapansin nyo na we have one unknown variable na lang, which is W. Okay? So, ano yung largest na rectangular field? So, tinatanong tayo ng dimension. We can solve for the area. Diba? Area yung, we want to know the space of the rectangular field, that is area. So, we will solve for the area of that rectangular field. So, A of, yung unknown variable natin is W, is length times width. So, ito yung length natin, 30 minus W times the width. Okay? So, simplify natin yung function natin. So, that is 30W minus W squared. And write it in the standard form, that is negative W squared plus 30W. So, again, yung W natin is yung H natin, ang vertex. So, yung H or yung W natin is equivalent to negative B over 2A. So, ano yung A natin dito? Our A is negative 1 and our B is 30. So, negative 30 divided by 2 times negative 1, that is negative 30 divided by negative 2, that is positive 15. So, yung W natin is 15. So, this is 15. So, ano naman yung length natin? Remember, this is our length. So, 30 minus 15 is also 15. So, basically, yung shape ng ating rectangular field is a square, and a square is a rectangle. For the length and the width of the rectangle should be 15 meters. So, equal yung length at saka width. which gives us the maximum area of the square. So we know that the square is a rectangle, so do not get confused. And the maximum area niya, so 15 times 15, that is 225 meter squared. Okay, examples for free falling bodies. So a ball is thrown vertically upward with a velocity of 40 meters per second. The height s of t of the ball above the building after t seconds. So hours time is in seconds, and that is the t is given by the function s of t is equal to 40t minus 5t squared. So yung height natin is actually the s of t. So how long? So how long yung time yung ina-ask niya? Will it take to reach the maximum height? So the maximum height is our vertex. So which is the h and the k. So in this case, yung h natin, that is the t, and then our k is the height, which is the s of t. Okay? So yung t natin is the h, so we can solve t by using the formula for h, which is negative b over 2a. So our a here is negative 5. Take note, it's negative 5. And our b is 40. So t is equal to negative of 40 divided by 2 times negative 5. So that is negative 40 divided by negative 10. So t is equal to 4. So hindi pwedeng mag-negative yung t natin because it's time. Therefore, how long will it take the object to reach the maximum height? It will be 4 seconds. Okay? Next, what maximum height will the object reach? So at 4 seconds, ano yung maximum height niya? So we will just substitute 4 to our formula s of t. So 4 na yung t natin. So 40 times 4, this is our t, minus 5 times 4 squared. This will give us the maximum height. So 40 times 4, that is 160 minus 5 times 16. So what is 5 times 16? That is equivalent to 80. So 160 minus 80 is equal to 80. Since height ito, the height is represented in meters. Therefore, the maximum height that the object will reach will be at 80 meters. C. Find the time at which the object is on the ground. So when the object is on the ground, it tells us that the height of that object is 0, right? So our s of t here is equivalent to 0 because it's on the ground. So writing the function s of t is equal to 40t minus 5t squared. So since it's on the ground, our s of t is 0. Okay, so 0 equals 40t minus 5t squared. So the equation is a quadratic equation. If you write it in the standard form, that is negative 5t squared plus 40t equals 0. So since the terms can be divided by negative 5, we have t squared minus 8t equals 0. So we can solve this by factoring, or we can do Vedic method. So our a is 1, our b is negative 8, and our c is 0. So multiplying a and c, that is 0. And we have to find two numbers that when multiplied, it will be 0, but if we add them, it will be negative 8. So that is 0 and negative 8, because 0 plus negative 8 is negative 8, but 0 times negative 8 is 0. So divide both sides by 1. So that is 0 and negative 8. So do not forget to flip or change the signs. So 0 has no sign, so that is 0 as is, and then negative 8 becomes positive 8. Therefore, our t is either 0 or t is 8. But since t is time and there was a movement in the object, because we want to know the time it reaches the ground, so there was a movement in the object, so t must not be 0. So we cannot use this one. So we will choose t equals 8 seconds. As a conclusion, the object will hit the ground 8 seconds after launch.